This video is going to cover Unit 24, Section 3, and Unit 24, Section 4. 24.3 deals with polygon internal and external angles. Okay, so it starts right out talking about a diagonal line. So a diagonal line is a line. So let's draw a polygon here. Notice I'm recycling paper. So I'm doing my part. So let's get a quadrilateral here. So do something like this. A diagonal is a line drawn from one angle to another angle, and the two angles are not adjacent. Non-adjacent vertices. So from here to here, for example. Perfect. What we get here is we form two triangles right here. And we already know that the angles of a triangle add up to be 180. So these angles add up to be 180. And let's see, this is a triangle, so this angle plus that angle plus that angle, let's think. I think they would add up to be 180 as well. Of course they do. So that means that a quadrilateral, interior angles on a quadrilateral would add up to be 360. So 360 degrees. Now another way we know this is if we take a square or a rectangle. We know that all of those angles in a rectangle are 90. So 90 plus 90 plus 90 plus 90. So 4 times 90 is equal to 360. So a four-sided object, the internal angles will all add up to be 360. So we know now that a triangle, the internal angles add up to be 180, and a quadrilateral, the internal angles add up to be 360. Okay, so you see near the top of page 601 in the blue box, it says the sum of the internal angles of a polygon can be found by this equation, which would be n minus 2 times 180. Okay, so let's test this on two polygons where we know what the answer is supposed to be to make sure it works. So this n represents the number of sides of the polygon. So a triangle we know has three sides. Well, it wouldn't be a triangle. So 3 minus 2 times 180. 3 minus 2 is 1. 1 times 180 is 180. A quadrilateral has 4. So 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180 is 360. Okay, so now I know that this equation works. So now I can use it on something like a 13-sided object. So what if I had a 13-sided object? What do all of those internal angles add up to be? So 13 minus 2 times 180. So 12 times 180, don't know that off the top of my head. So 180 times 12, 2,160 degrees. So a 13-sided object, if you added up all of the angles, would come to be 2,160 degrees. So these are internal angles. Let's see, what else do we have about internal angles? Not a lot. Now we're going to talk about external angles. Okay, so let me draw a figure here. try to get like a pentagon or something. Yeah, let's just do it this way. Five. Pentagon. Okay, so now we're talking about external angles. So what is an external angle exactly? This is something that we have to come to some kind of an agreement on what is meant by an external angle. So you might think, well, an external angle of this angle right here could be this whole angle right here, whatever that is. Okay, so that's not what we mean by an external angle. So look at page 602 at the bottom where it says external angles. Okay, so if a side of a polygon is extended, the angle between the extended side and the adjacent side is an external angle. So what in the world does that mean? So let's extend this side right here out. So this is the adjacent side. So this angle right here is an external angle. So now you have to keep the pattern going. You're not going to extend this angle and find this as an external angle. We have to keep the same pattern going. So I extended this way. So now I got to go to this line and extend that way. So that makes that an external angle. So now I extend this way, and that makes this an external angle. And that's an external angle. And that is an external angle. Okay? Now I could have went the other way. I could have started here, went that way, and then that way, and then that way. That would have been the same thing. So looking at figure 24-16 at the bottom of 602, it shows you how we come up with the external angles. Now, here's the special part of external angles of any polygon. They all add up to be 360. It does not matter. It does not matter how many sides the polygon has. It could have 100 sides. It could have 3 sides. It could have 5, 10, whatever. All of the external angles add up to be 360 of any polygon. So here's the formula for internal angles. And the formula for the sum of the external angles is right here. There's the formula for the external angle. They all add up to be 360. Okay? So taking a look at the example on page 603. So what they're looking for here is going to be angle A, I think. Determine angle A of the polygon. Okay? So let's look at the external angles. They're all listed there. None of them are missing. So we have, let me just draw that one close. So we've got a line coming this way, and then we've got this going out. So this right here is angle 6, and this is angle A right there. Well, what is angle 6? I don't know right now what it is. Let's find out. I have all of the rest of them, so all I need to do is say 360 minus 62 minus 80 minus, is that 25 or 26? 26 minus 58 minus 84. And I get negative 3,000, what? No, it's 50. So if angle 6 equals 50, then what does angle A equal? Well, here's a straight line. So this angle right here is 180. So angle A would equal 180 minus 50. So I already have it right there. So 180, or A is 130. Ta-da! Okay, so let's take a look at some other stuff here. I'm looking at page 605 at the bottom. Okay, so we're looking for some internal and some external angles. Okay, so we're looking at this one right here. Determine angle 1. So this is a quad, so you could run it through the formula, but we know that all of the angles here add up to be 360. So we just simply say 360 minus 92 minus 73 minus 108. So I kind of did those in the other. It doesn't matter. So that means that angle 1 is equal to 87. Okay, so let's take a look at this one. Oops, I got caught. Got my page caught on my camera. Right here. Okay, so I don't know what the sum of all these angles is supposed to be. So let's find out. So we've got 1, 2, 3, 4, 5, 6, 7. So this is a 7-sided object. So 7 minus 2 is 5, and 5 times 180 is 900. So all of these angles add up to be 900. So I'm just going to leave that 900 in there, and I'm going to, okay, so these are degrees, minutes, seconds. Okay, that's not a big deal. So I will subtract from that 98 degrees, minutes, seconds, 12 degrees, minutes, seconds, and then hit subtract again. 136, 57 minus 136 degrees, minutes, seconds, 18 degrees, minutes, seconds, minus 122 degrees, minutes, seconds, 43 degrees, minutes, seconds, minus 115, 12 minus 156, 14, now I forgot where I was. Isn't that hilarious? I'll just start over again. No big deal. 900. I lost track. You guys can look back at the video and see where I lost track. It's easy to do. Okay, 900. I'm going to start in this angle. That's going to be my first one. I think it was last time too. 98 degrees, minutes, seconds, 12 degrees, minutes, seconds. So if I go back around, yell at me. Yeah, you. Yep. 136 degrees, minutes, seconds, 57. I'm done starting over if I make a mistake. 136 minus 122 degrees, minutes, seconds, 43 degrees, minutes, seconds, minus 115 degrees, minutes, seconds, 12 degrees, minutes, seconds, and then minus 156 degrees, minutes, seconds, 14 degrees, minutes, seconds. Ding! Okay, So I get angle 3 is equal to 134.4 degrees. Now, if I wanted to stay consistent, I could change that to degrees, minutes, seconds, which means that it is 134 degrees, 24 minutes. Now, you do not have to do that, all right? The only time that we deal with degrees, minutes, seconds is when we're actually in those units, okay? I know that some of the homework, they're giving you the angles in degrees, minutes, seconds, and the only reason I give those problems out as homework is because I like the way they work out, not necessarily because they're in degrees, minutes, seconds. So you can convert them, or you can just work in degrees, minutes, seconds if you want. But you don't have to give your answer in degrees, minutes, seconds on those. You can convert them. I wish they'd just go with, decimal degrees. Okay, so that is internal angles. Now let's look at some external angles right here. We only need to really look at one example. Let's just look at this one right here. Yep, decimal degrees, good. So let me ask you the question, and I want to hear everybody answer. What do the external angles of that polygon add up to be? Now I want this one specifically. What do the external angles add up to be? Yep, they all add up to be 360. So to find, I think we have the one unknown right here. So 360 minus 38.72 minus 57.6 minus 30.3773, 30.73 minus 71 minus 88.67. So that angle is 73.28 degrees. Move it over a little bit so you can actually see the angle. Ta-da! It works. Okay, we're going a little long on this, so I will do the next video all on its own.